Welcome to my channel. In this video, let us study the reflection of light from spherical mirrors. What are spherical mirrors? It is a mirror whose reflecting surface is a part of a hollow sphere of glass. We all know that when reflection takes place from plane mirrors like this, then it is the incident light, and this is the normal, and this is the reflected light. So, the laws of reflection are the incident angle of incidence is equal to angle of reflection R, and the incident light and the normal and the reflected light, all three of them will lie in the same plane. And these laws of reflection will hold good even for spherical mirrors. Now, when you consider a spherical mirror, it is like this. How many different types of curved surfaces are there? Let's say I have concave mirror, convex mirror. Now, let us see what are these two. As per the definition, as we have seen, it is a part of a spherical mirror, spherical surface. So, if you consider this part, or if you consider this part, this forms this is coated outside and this is coated inside. So, this is the reflecting surface and this is the reflecting surface here, which is inward, and here which is outward. And if you look at the center of the sphere, when it is a part of that sphere, the center is here in front of the reflecting surface. So, this is the reflecting surface and here it is the reflecting surface. So, the center is in front of for the concave mirror. So, this is concave and this is convex. Here it is bulged. So, it is in front of, the center is in front of the reflecting surface, or we can say mirror, and here it is behind the mirror. Now, let us try to understand the components of these mirrors, spherical mirrors. So, components, what are these components? And these components are required to study in order to be able to calibrate for various practical applications. Now, before we go, let us quickly come to some examples of concave mirrors and convex mirrors. Here it is concave mirror, you have a makeup mirror or a torch light or car headlights. And in the case of convex mirrors, rear view, that is side view mirror, or security mirrors in shops and malls, where maximum can be seen. And concave mirror, it actually converges, and convex mirror diverges. So, these are the basic characteristics. Now, let us see components. Number 1, pole. It is the geometric center of the reflecting surface. So, whether it is concave or convex, so this forms, so this is on the surface of the reflecting mirror. So, this forms the pole and it is denoted with the letter P. So, it is in the middle of the surface MN. This is concave and this is convex. Then the next one is center of curvature. the center of curvature is denoted with a letter C, and in this one it is not on the surface of the mirror, and it is not as a part of the surface, but it is a part of the spherical part of which the reflecting surface is a part. So, this is the center. Now, this center lies in front of the reflecting surface, as I already mentioned. So, this is the center. Similarly, here for the convex lens, so this is the center. So, of which this forms a sphere. The next is radius of curvature. It is denoted as R. Now, the line joining the pole and the center and the length P of that PC is equal to R. That means, if you join this length, so this is equal to R. If you consider any other point on the surface, then that also forms R. So, P or any point on the surface to the center is also a radius of that sphere, and the radius of that sphere is the radius of curvature of the reflecting surface or the spherical mirror, concave or convex. Then principal axis, the line joining P and C, which is perpendicular at pole P to the surface of the mirror. So, this is an imaginary line which is running between minus infinity to infinity, and which will be perpendicular or normal to the surface at the point P. Then we will have principal focus or focal point. Focal point is denoted as F. If you take a concave mirror, so this is the coated and this is the, now this is P, and this, if a light is incident at this point, at any point it acts like a plane mirror, therefore it reflects, and the normal will be passing through the center. Any line will reflect and intersect and come back to this point, all the reflected. So, this is the incident, this is the reflected, this is the reflected, this is the reflected, this is the reflected, this is the incident. So, all these different rays will reflect and come to an intersection point called F, and that is what is called principal focus. So, a concave mirror converges, brings to focus the reflected light to a single point. And in the case of a convex mirror, the light appears to diverge that means this reflects like this, so these are the incident light and these are the reflected light, and this is P. So, this point is F. So, it actually appears to diverge from this point. So, here convex, it is a virtual focus, and in this case it is concave real focus. Then focal plane and focal length. A plane through this principal focus is called focal plane. And the distance between the focus and the pole is called focal length. So that is the length from pole to principal focus is the distance called focal length, which is equal to small f. Then finally, let us see what is aperture. It actually denotes the size of the mirror. It is the diameter of the reflecting surface, mn, which is usually much smaller than the radius of curvature r. And for small radius of curvatures, if we assume, then r will be equal to 2f, which means the principal focus lies midway or in between pole and the center of curvature C. In my next video, we will discuss how images are formed using these spherical mirrors. Until then, keep watching, keep learning. Thank you.